Okay, so let's practice what we learned. In this case, our b is equal to 2, so this is greater than 1, so I'm expecting a vertical compression in this graph. So I'm still stuck on vertical. I'm expecting a horizontal compression on this graph. So our normal period is from 0 to 2 pi. Our new period, right, is going to be 2 pi over my b. So 2 pi over 2, which is pi. So all our action is, rather than taking a full rotation to go through all action, it's only going to take us a half rotation to go through all our action of sine. So that sine wave is not going to be over 0 to 2 pi. It's going to be compressed. And how do we do that? We'll again manipulate points, right? Our core points on a sine graph are 0, 0, pi over 2 and 1, pi and 0, 3 pi over 2 and negative 1, and 2 pi. And because we're dividing, right, because we're dividing our endpoint by b, and even that means all the values within that normal period are being divided by b. So we are basically going to be dividing by 2, right, in all these cases. So if I take 0 and divide it by 2, let me start doing this in red. So these aren't going to change, right? We're not impacting the outputs. But if I take 0 and divide it by 2, I get 0, right? If I take pi over 2 and divide it by 2, right, that's the same thing as taking pi over 2 and multiplying it by a half. So we get pi over 4. If we divide pi by 2, we obviously get pi over 2. 3 pi over 2 divided by 2, well, that's the same thing as multiplying by 1/2. So we get 3 pi over 4. And if I take 2 pi and divide it by 2, we end up with pi. So you can see, right, the endpoints used to be from 0 to 2 pi, but now they're happening from 0 to pi. So if we go graph this, let me kind of mess around with the scale. Right, so we have pi over 2, right? We have pi over 4, pi over 2, 3 pi over 4, and pi, right? And we're still between 1 and negative 1. So on this graph, we're going to start at 0, 0. Pi over 4 is 1. Pi over 2 is 0. 3 pi over 4 is negative 1. And pi is 0. So in red, right, there would be a graph of sine of 2x. To give this perspective, right, here's pi over 2, which would mean that this would be 3 pi over 2, which would mean that's 2 pi. So in blue, right, what does a normal sine graph look like? Well, it starts at 0, 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's negative 1. And at 2 pi, it's 0. So in blue, here's what the normal sine graph looks like. So all the action that used to take us one full rotation in blue, right, is now being done in a half rotation between 0 and pi. So the period has now changed. And kind of looking ahead, what this also means, if we were to continue on, right, because this graph would just continue on and on and on, notice that what used to be one full cycle in blue, right, is now 2 full cycles, right, in red, because we've taken the period and we've cut it in half. And so now we're getting into the frequency kind of argument, which I'm way ahead of myself. We won't talk about that till 4.5. But you can almost see that happening right now. So under a full rotation, in blue is what sine's supposed to do. But because I'm taking the input and multiplying it by 2, I've in effect taken the period and cut it in half. So the sine's going to go up and down and back up in half a rotation in what it used to do in a full rotation. Net effect is we have vertically compressed, we have horizontally compressed, all right, the sine function. We went from here to there, so kind of like a band or an accordion, all right? So what about sine of 1/2 x? Well, again, in this case, our b is equal to, let me write it in blue, our b is equal to 1/2. This sits between 1, so what I'm expecting is a horizontal stretch. right? What's the new period? The new period is 2 pi, right, divided by b. In this case, this is 2 pi divided by 1/2. Of course, if I divide by a fraction, I multiply by its reciprocal, so we get 4 pi. So what used to happen over 0 to 2 pi is now happening from 0 to 4 pi. All right, and so you can see that we've basically all the action used to happen in one rotation. We actually need to go through 2 rotations just to get one complete sine graph in there. And so here's how we're going to do that. Again, I just like to manipulate points. So what are the core points on a sine graph? 0, 0, pi over 2, 1, pi and 0, 3 pi over 2, -1, and 2 pi 0. And again, what we're doing is taking all the x values, right? If I divide the period by b, I got to divide all these by 1/2. Of course, when we divide by 1/2, we're actually multiplying by the reciprocal. So in a net effect, we're multiplying these all by 2. And so again, my new graph, the y values are not being impacted. This is all happening to x. And dividing by 1/2 means multiply by 2. So 0 times 2 is 0. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. And 2 pi times 2 is 4 pi. So you can physically see what happened is all the action on a normal sine graph has now been elongated for the sine of a half graph. And so when we go graph this, paying attention to my scale, we can still be 1 and -1 along the y-axis, but here we're going to go pi and 2 pi and 3 pi and 4 pi. And so in red, what I have is 0, 0 on the graph. I have pi 1 on the graph. I got 2 pi 0. I got 3 pi -1. And I got 4 pi 0. So in red, here is one complete cycle, right, of sine of 1/2 x. Right? In blue, right, the normal sine graph would be at 0, 0, pi over 2, 1, right? It'd be at 0, 3 pi over 2, -1, and 1. So here's what the action would look like in blue. There's our sine graph. So you can see what happened is if the sine graph, right, has been elongated. It's like we took our accordion and we stretched it out. So one full rotation and a normal sine has now been stretched, right, to get that normal sine wave action over one cycle. We actually have to stretch it out from 0 to 4 pi. And hopefully you're seeing the value. If you know those core points, all you have to manipulate is the x and the y values accordingly to what we've been doing. And if you just do that and you mark it, everything else, how you scale everything is going to become easy. How the graph's going to look is going to come easy. And then, of course, if you wanted more cycles, we do more cycles, right? I guess this would be at 6 pi, and eventually we'd be at 8 pi. And so the graph would look like that, or back and forth. So we can repeat this action over and over and over again, but we have a period change. I'm 8 minutes into this, there's sine. How about I save the next video and we'll manipulate cosine in a similar manner.